Hi, MES students. You had talked to us about wanting some help with DAQs, and so Nathan asked if I would put just a quick video together to give you some of the basics, because the DAQs can be confusing. So that's what I'm going to do here. So first thing, let me show you the hardware that I've got. So I have two power supplies. You see this one right here, this one right here. And I'm using the module that you guys use in, whoops, here we go. I'm using the module that you guys use in lab, the 9219. Now, if you Google this module, you'll get the manual from NI that shows kind of the wiring. Also, most of the modules, if you look at the side of it, it tells you. So you probably can't read this, but I'm looking right here and it says voltage number 4 and number 5. So 4 is high or positive and 5 is low. So that's where I'm going to plug things in. So if you look on the sides of the module, again, you won't be able to see it. You'll see numbers. So over here, I see 1, 2, 3. And then over on this side, I see 4 and 5. So the power supply on the right, I've already wired in right here. And you notice it's in the top two. That's 4 and 5. And I'm going to do the same thing with the ones on the top here. Now, one trick I want to tell you is when you insert these, you push it down, put the wire in, make sure you pull on the wire to make sure that it's in good. So I'm going to go ahead and put this module back in the rack, put the other wire in, and then we'll start the program. So I'm going to start up LabView, open up a blank VI. Go big on both of these. So now I'm going to go to the block diagram, and I need to insert the DAQ block. So I'm going to right click, go to measurement IO, NI DAQ, and then there's the DAQ assistant. So I'm going to drop it down. And now it's asking me what I want to do. Now let's talk for just a second. What is the DAQ? So if I look over at this piece of hardware, this device right here is what allows the computer to interface with the real world. It allows signals to come in here. It can allow voltage, it can allow current, it can read really fast, it can read all different kinds of ranges. Like we put accelerometers into here. Accelerometers are just voltage, but the voltage is moving really fast, and these can read that. So it takes this analog voltage and it turns it into a digital signal, sends it through the computer, and then able to display for us. So when our program goes to take a reading, what it does is our program sends a message to this device, and it tells it to take a reading, and then it sends that reading back. So in our program right here, it's asking us, do we want to acquire a signal or do we want to generate a signal? Like you're going to see on the wind tunnel, the speed can be controlled by a voltage. So we can write a LabView program that generates signals, and that generates between 0 and 10 volts. So we could turn a knob in LabView. That would cause the DAQ, an output module on the DAQ, to output voltage. It would go into the wind tunnel and make the speed change. In fact, you all are going to use that on your pitot tube lab. But for us, we want to read a voltage. We want to acquire a signal. So we're going to open up this. There's different kinds of input. For us, we want an analog. That means we have a voltage that's changing in an analog, not digital like on or off. And we have a voltage. And temperature, strain, all these other things, the only difference is they're all voltages. It's just LabView automatically builds in a conversion factor, a calibration factor, to go from the voltage to a temperature or to a strain or to different things that we're reading. So we're going to read just a plain voltage. And now what it does is it goes and looks at our physical device right here. Sorry about that. I keep messing. Our physical device. And if you notice, we have something plugged in this very first slot. So if you look back on our program, it's telling us we have a 9219 plugged in number 1 right there. Very cool. I open that up, And now what do I want to read? I want to read 0 and 1. So I'm going to say I want to read 0 and 1. I want to read both of them. I say finish. And it's going to bring it into my program. And it allows me to change some things. Now, down here at the bottom, acquisition mode. So let me explain this to you. You see down here, it says N samples, number of samples to read, 10, the rate. How many am I going to read per second? So if I set it like that, here's what would happen. Every time my program hit this DAQ block in the program would basically stop. It would move over to this hardware device right here. Yep, there we go, I can see it. And it would tell it, give me 10 samples at this sample rate. This guy would take that many samples, let's say it was 1,000. It would take 1,000 samples. The whole time our program is stopped there waiting for it. It would take 1,000 samples. It would then transfer 1,000 back to here. And our program, when it came out of this blue block, would then have 1,000 samples in its hand that I would have to do something with. I could put 1,000 on a graph. I could average the 1,000. I could display the 1,000. But that's what this N samples is working. And we will actually use that later when we want to take samples over time and average them. Right now, we want to see what we're doing live. So we're just going to get one sample. We're only going to read one sample. And then down here, this module that we have goes from -60 to plus 60 volts. We could leave it at that. Now, my power supplies don't go that high. I don't remember exactly how high they go. I know they don't go negative. So to give myself a better range, more resolution, I'm going to narrow that. So I'm going to go from 0 to 15 volts. That's as far as I'm going to go. What that's doing is that's giving me better resolution in what I'm going to read. Also, most of the modules, they have some settings. So this one has high resolution mode and it has high speed mode. It also has some noise reduction modes. Well, what's the difference? Well, you'll see. High resolution gives you the most accurate reading that you can, but it's slow. How slow? Well, if you open up that manual, it's going to tell you how slow. If you went and Googled it, I'm going to set it for high speed right now so that it's going to collect as fast as we can. Okay, so now we think we have all this set up. We've read those two right there. And one thing I can do is I can right click on this and I can rename it. And let's call it left power supply. And let's call this one right here right. Well, how do I know which is which? Because remember, the one, whoops, and I said that wrong. The one on the right is hooked up to the bottom. That's number 5. And so this is oh, I said that right. Right power supply. Okay, and then I'm going to click details right here. Okay, AI 0. What's AI 0? Well, this module has 1, 2, 3, 4 inputs. Let me walk down here. This module has 1, 2, 3, 4 inputs. That's AI 0, AI 1, AI 2, AI 3. All the modules start with 0. So let's go and look. So the top one is AI 0. That's hooked to my left power supply. Yep, that is correct. So I called that left power supply AI 0. This is AI 1, and that's hooked to my right power supply. See my wire right here? This is hooked to my right. This is hooked to my left, okay? So that's the naming. AI0, how do I know that? Well, it says it on this module right here. If you look, let's see if I can actually get this where it reads it, but right here it says channel 0, channel 1, channel 2, channel 3. And that's the way all the NI modules work. They're 0, 1, 2, and 3. They're, from an array standpoint from MATLAB, as you'll learn, they're all 0 indexed. Okay, so I'm going to hide the details. As far as I know, and I better spell that guy right. There we go. That looks better for everybody. I'll set my range. Oh, and I set it for the top one. I need to set it for the bottom one. I didn't do that. So 0, 15. But this setting is for the device. So anything that I'm reading is going to get changed with this setting. But you see, these two, the ranges could be different for each channel. So I've got that set. Okay, that makes sense. Now, one more thing that I like to do, before I go into my program, I like to come right up here and say run and check and see if I'm actually reading anything. And you're like, what in the world is that? That mu, that's and I always forget, it's my 10 to the minus whatever. So it's really, really small. Well, that's because my power supply isn't reading anything. So I'm going to turn the voltage up on my power supply. Now it's reading 1.6, and lo and behold, it's reading 1.6. On my right one, I'm going to turn it down. It's going down. It's going up. Okay, beautiful. Now I know I'm actually reading from my DAQ. Now I don't have, if I'm not getting something, I know it's something in my program. This tells me that my wiring, my setup is all correct, that I am actually reading from my DAQ. Okay, that's beautiful. Everything's good. There we go. I got my screen fixed, so now I'm going to say okay. Lo and behold, there it is. So now, when I hit this block, it goes and reads one thing. Well, I want it to continually read, so I need to put this inside of a loop. So I'm going to right click, I'm going to look for structures, and I'm going to say while loop, and I'm going to draw a big while loop around. And you see the little stop sign, that's what ends it. So I'm going to right click on the stop sign and say create control. That'll make me a button. If I go and look on my front panel now, I have a little stop button. And that's kind of a trick. If you right click on anything, it'll kind of let you know what you can do. So what this would do now is this would just loop around and keep reading this. I'm going to come right here and I'm going to right click and I'm going to say create a numeric indicator. So let's go look on my front panel. There it is right there. And you're like, well, wait a minute, we're reading two things. How can that work? Well, it can't. We need to see the two different things we're reading. So I'm going to delete this. There's two ways that, and I'm going to hit Control B to clean that up. There's two ways we can get the individual signals. Here's the first way. I'm going to right click. Look right here, signal manipulation palette. There's a lot of cool things in here. I want to split out my signals because I'm reading two different things. So I'm going to click that, put it right here. Let me connect these. And now I can drag it. I'm reading two things, so I drug it for two things. Now I can come right here and I can right click and I can say create numeric indicator, and I'm going to move this up here and I'm going to say, okay, the first thing I read is the left power supply, so I'm going to call this left, and then I'm going to right click right here and I'm going to say create numeric indicator, and I'm going to double click and I'm going to say right. Okay, so what's our program going to do? It's just going to keep looping, and it's going to read one thing, put the first thing it reads up here, the second thing it reads down here. Well, what's the first thing it reads? I double clicked on my little blue box. The first thing is left, the second thing is right. Okay, so that's why I named them that way. So now I could go to my front panel and I could run this, and there it is. So I'm going to turn the knob on my left and look at it changing. I could turn the knob on my right. Yep, and now look at it changing. Very nice. And now it might be changing too fast. I may not want it to change that fast. What's controlling how fast it's changing? What's controlling it is how fast this module can read. I may want it to read slower. So what I'm going to do is I'm going to right click and I'm going to look for a timing function. So let me right click again. There's timing. And here's a wait millisecond. So I'm going to put that in here. What this function does, like what does it do? Well, look, I'm going to click right here. And let me pull this guy over on our screen. This is really handy. Once you click that, when you roll over something, it gives you the details of it. So it waits a certain amount of milliseconds. What determines how long it waits? Whatever's wired to the front of it right there. So I'm going to close that up. So now I'm going to come to the front and I'm going to right click and I'm going to say create a control. I could have also created a constant. That would have just let me type a number. But I don't want to do that. I want it to be able to change it. So I'm going to undo and I'm going to right click and I'm going to say create a control. So now when I go to my screen right here, I have milliseconds to wait. So now I'm going to run my program. And you see that? Well, now I'm going to put in 300. Now I'm going to put in 600. Now you see how my sample rate is slowing down. Now I'm going to put in 1,000. That means it's going to take one every second. You see there? So that's how you can control your sample rate. And if I put in 100, let's put in 0. You see it going? Now if I put in 100, I'm not sure it slowed down any. Why not? Well, because it can only go as fast as that module goes. How fast can that module go? I don't know. I would have to pull the specs up to see it. But here's what I do want to show you. I'm going to turn it off. Now I'm going to come in here. And remember I told you there were two modes. Now I'm going to put it on high resolution mode. And I want you to see how much slower it goes. So go to the front panel. I'm going to run it again. Now, look how slow it's changing. I think it's about 1 a second. On high resolution mode, that's as fast as that module goes. You know, so notice even if I put 0 right there, it's not going to go any faster. Even if I put like 800, it's not going to go any slower because the module is controlling it, okay? So let's stop it again. And then one last thing. If I read 5 things, I would just drag this down for 5 and then be able to see all those. I only need 2. I don't know why he won't let me go back up and collapse that last one. Oh well. So when I run it, he's still happy, even though I have an extra one down there. He's still fine. So I'm going to leave it. So I'm going to go back to here, change this back to high speed because we don't need the high resolution. And then the last thing I want to show you is now you have the 2 things you're reading and you can do math on them if you want to. So let's say I wanted to add 10 to the top one. So I could right click, I could say numeric, I could find my add button and drop it in. And now I'm going to hook this, and let's hook it up to the bottom. And now to the top, I could create a constant and put 10. Now, let's do, and I think I may have, is that an add or a divide? I can't see. It's going to be easy right here. Oh yeah, that is an add. It looked like a divide sign. Cool, I'm going to close him. Now I'm going to do the same thing. I'm going to say numeric, and I'm going to say add, and I'm going to go like this, and I'm going to do the bottom one, put him right in there. Now I'm going to right click, and I'm going to say create control. And I'm going to name this add to right. So you see, by putting a control instead of a constant, show my front panel, it gave me a control, something that I can do. So look, I'm going to run it now. And add to right. So look what happens if I put 10. Oh, wait a minute. That was dumb. I don't ever display this. You see, I'm displaying the raw numbers right there. So if I want to see this number, I have to right click, create numeric indicator, and I'm going to say right click, create numeric indicator. Numeric and numeric too. So let me call this left new and call this right new. Go back to our front panel, and they kind of now run it. So now you can see add to the right. Look at our top one, it's changing because what I'm adding to it. And then so from here, you can do whatever math you need to do. If I needed to do more math, I would just keep trailing them together. Okay, so that is the basics of using a DAQ right there. You look and see how to wire it correctly. You then come in here and add. You can change the range that you're reading. You can change the names. Once you have it all set up, you can go here to see what the actual channels are. Then this is a great trick to check right before you go and do it. Okay, cool. Great. I want to show you one more thing. Now, what I'm going to do is I'm going to come over here. I'm going to pull this module out, and I'm going to put it in somewhere else. Okay, you see it? Now, anytime one of these gets moved to another computer or whatever, this is what happens. So, here's what's going to happen. I'm going to come in here, and I'm going to run my program, and it won't run. It's like, we can't find that module. Why not? Well, because I told it was in slot number 1. So a lot of times when you run one of the programs that we give you, you have to go in and reconnect the points to the new module location where it is. So here's what you're going to do. You're going to double click on this. You're going to open this up so you can see, okay, this is supposed to be AI0. And now I'm going to right click on it. I'm going to say change physical channel. Now I'm going to click on which one again? AI0. And so what it's doing is, instead of clicking on it in slot 1, it's clicking on it down there in slot number 4. 1, 2, 3, 4. So I say OK. Notice how it changed from 1 to 4. Now I'm going to do the same with this one. Change physical channel. I'm going to open it up. Which one do I pick? I want the same thing. It's AI1. AI1, OK. And I can close this just so you see everything's still the same. I say OK. Let it rework. And so every DAQ block in your program, you would need to go and do that to. if the module has gotten moved or it's a different one on a different computer. So I'm going to say go, and lo and behold, look, now my program is running. I move the right one, it's going up and down. I move the left one, it's going up and down. Okay, one last thing I thought it was worth showing you. First, I want to mention, I told you there were 2 ways to get multiple signals. This is the first way. I'll show you the second way in another video because I'm also going to combine it with a different way to do math. But right now, I just want to show you graphs. So the easiest way to do a graph when you have multiple signals, the first way is to just come right here, right click, remember down here this create, and say create graph indicator. That's really cool. The only problem is if you run your program, it's not going to work because we don't have a graph. A graph is when you have a bunch of numbers and you want to graph them. So like if we had told it to take n and 1,000, it would graph all of those 1,000. We want to do one at a time and keep adding it. So what you're going to have to do now is go to the front panel, right click on this and say replace, go to graph. We want a chart. We don't want a graph, we want a chart. A chart's going to put it on there one at a time. So now if I run it, I'm going to see my 2 things there. And so now if I turn the knob on one of them, I'm going to be able to see it change live. And there's ways to slow the graph down, to add more to it. Nathan can help you with that because that's the same with all graphing. But this shows how you get it in working with your DAQ. The other thing I could have done, and I'm going to come down here to block diagram, is I'm going to take this and I'm going to say edit, copy, and I'm going to create another graph. Let's give it another name, another. So if I go to my front panel, they're both going to be there. There's the one, there's the other. And now what I could do is I want to get 2 signals into this. Well, I could go to my signal palette here and oh, there's a combine. I could use that. A lot of times, and I always try this first, LabView will do things for you. So I'm going to wire that one. Let's say I want to graph the 2 ones that I did math on. So now I'm going to go right here. Whoops, I didn't get there we go. And I'm going to go right there. And lo and behold, look what it did for me. Get this guy out of the way. It added that. So now if I come up here and I run it, doesn't look like it's the same, but look at the scale, how it's different. And you remember we're adding 10 and 20. And so that's how you get your graphs going. If all you want to do is graph them, the raw numbers, just come right up here and add it. If you want to graph what you've done math on, you can just come right here and then add them back together and it'll put them all on one chart. When you're doing more advanced math, there's another tool that'll combine them in the graph, but that will be for the other video. Okay, so I hope this helps and good luck as you're trying to learn more about DAQs and to use these.